Assalamualaikum warahmatullahi ta'ala wabarakatuh. So, for today's video, we've been given a task by our lecturer to create a video about topics that we learn from our subject, which is calculus. So, from our group, we basically choose topic about rates of change. So, before we going through our main topic or our main discussion, let me introduce our groups. So my name is Muhammad Ajwad bin Azmi, and I'm from J4EE 1112 A1, and my members are Aiman HAKIM bin Azmi, and the other one is AQASYA bin Azmi. So we together create this video, and we'll explain to all of you about what is about rates of change. For our introduction is about our definition is about differentiation and related rates. So rates of change, what is actually meant by rates of change? So basically in rates of change there are also differentiation and related rates. So what is meant by differentiation is the definition of differentiation is in mathematics a process of finding the derivative of rate of change of a function in contrast to the abstract nature of the theory behind it. The practical technique of differentiation can be carried out by purely algebraic manipulations using three basic derivatives, four rules of operation, and a knowledge of how to manipulate functions. So for the next definition is about related rates. So rates could be defined as a problem which involves at least two changing quantities and asks you to figure out at a rate at which one is changing given sufficient information on all of the others. For example, as two vehicles drive in different directions, we should be able to deduce the speed at which they are separating if we know the individual speeds and directions. I think that's all from me. For my part, which is definition, I explained to you just now about definition of differentiation and also related rates. So I will pass to my other members to explain detail about our topics.
Well, thank you, Ajwad. So, hi guys, it's me, Aiman. So, you already know about the definition of differentiation and related rates. So, I'm going to tell you guys about the method to solve the related rates. So, first of all, we need to identify the given related rates and the related rates that we need to find. After that, we need to interpret both of these rates as a derivative of a variable with respect to time. In this case, you need to remember that we need to put a description for each of the variable that involved. Secondly, we need to find an equation that relates to the variables in step 1. So for example, if the question asks about geometrical problems, we need to draw the diagram and show the relationship involving the variables, like for example a cylinder, a sphere, or cuboid, yeah, something like that. And thirdly, we need to differentiate this equation. So in order to differentiate this equation, we can use the method of implicit or chain rule. So but for me, I suggest to you to use chain rule because it is a lot more easier compared to using implicit rule. Then we can calculate the equation that we found in step 3 by using the known values for the quantities and their rate of change. Finally, step 5, we can solve the value of the remaining rate of change. So these are the steps of solving a related rates problem. So I'm going to pass to my friend AQASYA to explain more about how we can apply these steps to solve the related rates problem that we face in our daily life.
Hello guys, it's me, AQASYA. So, I'm going to explain about a situation. It's quite simple actually, that we can relate with related rates. So, I have a balloon right here. Okay. I have filled up the balloon with air. So, let's assume that the diameter for this balloon is 25 cm. So I am going to let the air run out of this balloon. Okay, so let's assume that the time taken for the air to run out is 2.5 seconds. So with this value, we're going to find the rate of change of volume for this balloon. So let's get right. So I have written the solution for this problem first, so I can explain it to you. So we already assume that the diameter is 25 cm. Then the time taken for the air to run out is 2.5 seconds. So we need the radius. So we already know to find the radius. The radius is half of the diameter. So to find the rate of change of radius, we need to subtract the final radius and the initial radius, then divided by the time taken. Then we get the rate of change of radius, which is negative 5 cm per second. We get a negative value because the balloon deflated. So this is the formula for volume of volume of sphere. So we assume that the balloon is spherical. So this is the solution for the rate of change of volume. So to find the rate of change of volume, which is dv over dt, we need to multiply dv over dr and dr over dt. So we already get the dr over dt, which is the rate of change of radius, and the value is negative 5 cm per second. So since this is dv over dr, the r becomes r square instead of r cube, because they divide the r. Then we just put the value for the radius. So after calculate, we get the final answer is negative 3272.5 cm cube over second.
In conclusion, we know that there are many situations or problems that we face in our daily life that we can solve using these related rates. So that's all from us. I hope you guys can learn or gain something from this video. Hope to see you soon. Bye.